Let's look at this 2D equilibrium example problem. We have a block weighing 100 pounds suspended by 3 ropes as shown in the figure. We know that the tension in rope C is 20 pounds. Given that, what are the tensions in rope A and rope B? Okay, so the first thing we'll do is set up our coordinate system, XY, and we will draw a free body diagram of point P. Put that at the center. And let's start with rope C. So we're going to cut P away from its surroundings, which are rope C, rope B, rope A, and then the 100-pound weight. So we'll start with rope C, and we'll draw a force vector at 10 degrees from the x-axis and label it with a magnitude of 20 pounds. Now let's look at rope B. It's at an angle of 50 degrees from the y-axis. We don't know the tension in rope B. That's one of our unknowns. We'll call that T sub B. Rope A, over here, this quadrant is going off at a 30-degree angle with respect to the negative x-axis, and its tension is unknown. And then the 100-pound weight is acting straight down, and we know its tension at 100 pounds. Okay. Now, as discussed in the lecture, we know this system is in equilibrium. So the sum of the forces acting on P equals 0. And we can rewrite that we can express that in the two scalar equations. Sum of the forces in the x direction equals 0. Sum of the forces in the y direction equals 0. Okay, so we have two equations. Let's look at our free body diagram and see how many unknowns we have. The only unknowns are the magnitude of T sub A and T sub B. Their directions are known. The tension in rope C is known along with its direction, and the 100-pound weight has known magnitude and direction. So with two equations and two unknowns, we should be able to solve the problem. Now, if we had more unknowns than we did equations, we would either have to find a way to write more equations with another free body diagram possibly, or declare that the problem's unsolvable with the information given. So let's sum forces in the x direction. So I'm going to need the x component of each of the forces shown. So I'll do those in color here. The x component of T sub A is going to be this force here. The x component of the 20-pound force is going to be this force here. And the x component of T sub B, since they gave the angle from the y axis, just for convenience, I'm going to draw it up here so it's easier to see the triangle there. Okay, so I'm going to express those in this equation, given the unknowns and the knowns that I have. So for the x component of T sub A is going to be minus T sub A times cosine 30 T sub B, the x component of that, is going to be plus T sub B times the sine of 50, because they gave us that angle measured from the y-axis, so it's going to be sine instead of cosine. And the 20-pound force, the x component of that is going to be 20 times cosine of 10 degrees. And all of that is going to be equal to 0. I'm going to go back to black here. Okay. So I do that math and I get negative 0.866 T sub A plus 0.766 T sub B. I'm going to take the constant on the other side of the equal sign, and that's going to be minus 19.7. Now I've rounded all these for the purposes of my written work, but I'm keeping each of these numbers, the 0.866, the 0.766, the negative 19.7, all those are in my calculator stored out to their maximum number of decimal places. So when I get ready to reuse this equation here in a minute, I'm going to pull those numbers out of memory, not just enter what's written on my paper. Okay, so we have one equation there with two unknowns, so we know we're going to have to write another equation. Some of the forces in the y direction equals, so for y I'll use purple here. The y component of T sub A is going to be right here. The y component of T sub B is going to be there. And the y component of the 20-pound force tension is there. And the 100-pound force also acts in the negative y direction. So I need to make sure I don't forget about that when I write my equation. So I'll write my forces in the y direction in purple. So I'm going to have T sub A sine 30 plus t sub b cosine 30. Nope, that's wrong. T sub b cosine 50. It's easy to make these mistakes. You just have to be vigilant and work through force by force. It's going to be t sub b cosine 50. And 20 sine 10 degrees minus, because the 100-pound force is going in the negative direction, 100 equals 0. Okay, now I'm going to simplify all that, and I'm going to have 0.5 t sub a plus 0.643 t sub b, and these two terms here are both just numbers. I'm going to combine them and take them to the other side of the equal sign, and they are 96.5. So I've got a second equation now in t sub a and t sub b. Here's my first equation, called equation 1. Here's my second equation, equation 2. Two unknowns, so I know I can solve for them, decide what method I want to use to solve the equations, and I'll use substitution. So I'm going to go back up to the first equation and solve for t sub b in terms of t sub a. And if I do that, I get t sub b equals minus 25.71 plus 1.131 t sub a. T sub a. Now, having t sub b expressed in terms of t sub a, I can substitute that into my second equation, and I'll write that out. So I'll have 0.5 t sub a plus 0.643. Now for t sub b, I'm going to substitute in what I have for t sub b out of equation 1, which is minus 25.71 plus 1.131 t sub a equals 96.5. And when I do that math, it's just algebra here, I'm going to have t sub a equals 92.2 pounds. Now I can, to solve for t sub b, I can substitute that into either equation. I'm going to substitute it back into the first equation. So now I'm going to take t sub a, my value for t sub a, and substitute it back into equation 1. And I'll write that out. That will be 0.866 times t sub a, which I just solved to be 92.2. Now again, that 92.2 number, you need to have that saved in your calculator memory with all its decimal places, or else you're going to throw your second answer off. And then this will be plus 0.766 T sub B equals minus 19.7. And if you do that math, you'll get T sub E equals 78.5 pounds. So here are your two answers to the problem.